So sometimes, in addition to finding the median, it is going to be useful to know the number or proportion of scores that lie above or below a particular point. And that's what we did yesterday when we were talking about what percent of people fell below a score of 8 or something like that, or time of 8 or something like that. So what you're going to do is you're going to construct a cumulative frequency distribution table if you didn't already have one. Construct a cumulative distribution table and a cumulative frequency graph to represent the data. Percentiles are something that you're all familiar with because that you've gotten your ACT and SAT scores. Your score is always given a percentile. You are in the 80th percentile or something like that. A percentile is the score which a certain percentage of the data lies at or below. That's why you can't be the 100th percentile, because that would mean that you are better than 100% of the people who took the test, but that includes you, which doesn't make any sense. So it says, for example, the 85th percentile is a score of which 85% of the data lies at or below. So if you are in the 85th percentile in a room of 100 people, you are better than 84 of them. Or better than 85 of them, excuse me. I'll be all right. If you score in the 95th percentile, then 95% of the class has scored the same or less than you. So it's less than or equal to. The lower quartile, Q1, this is not the, ew. Ew. Okay, the lower quartile, Q1, is the 25th percentile. Median Q2 is the 50th percentile. And Q3 is going to be the 75th percentile. That should be pretty obvious, right? Now this table shows the results of the women's marathon at the 2008 Olympics for all competitors who finished the race. We've been asked to do a lot of things with it, and there was nowhere near enough space on the front of this page, and that's why it says flip it over to do it. So on the back, I have the table again, I believe, and the questions again. But on the back, you will notice that I've reconstructed the table and I added the cumulative frequency column. I only have part C on the back. Part A was to construct a cumulative frequency distribution table. Part B was to represent the data on a cumulative frequency graph, which is down below. So part A, let's make our cumulative frequency column filled up. So remember, this is a race, so lower times equals better, right? The first group of people from 2 hours 26 minutes to 2 hours 28 minutes was 8. So the cumulative frequency at that point is just 8, right? But the next group from 2:28 to 2:30, there's 3 more people. So at this point, we have 11 people finishing the race. 9 more from 2:30 to 2:32. So now 20 people have finished the race. Then 11 more. Yeah, thank you for that. And then 43. And then 50. 55. 63. And then, so there were 69 people in this marathon. Part B is to construct a cumulative frequency graph, and that is down below. Now, unfortunately, I can't see this table of data and the graph at the same time on my screen. So rather than scroll up and down, I'm going to use the one that's in my hands, okay? But what we're doing is we're basically plotting points that we just generated. And I can't even see my whole table, so I will have to scroll up and down for that. I tried my best to make the copier make these lines dark. On the IB exam questions, the lines are dark. and they always land on, well, the things they're asking for always land right on what looks like an actual point. It'll never be a in-betweener. Okay. So we know that the first group of people was 2 hours, 26 minutes, which I have right here, this right here, 226 to 228. Now, the hardest thing about this is the scale, because you can see that my next one went up to 2 hours, 30 minutes, right? That's 4 minutes. But how many tick marks is it? 1, 2, 3, 4, whoa. I actually mean to write on the panel. 1, 2, 3, 4, 5, 6, 7, 8 tick marks. So that means each tick mark is a half. Each tick mark is 30 seconds. Cool? Okay. So we're supposed to go from 2 hours, 26 minutes, which is from here, to 2 hours, 28 minutes. That's 2 minutes. So that's there. Because mine goes by 4 minutes, our groups are 2 minutes apart. Cool with that? So the first point is technically a 0 if you want to think about it, when nobody finished below 2 hours, 26 minutes. But we do know that between 2 hours, 26 minutes and 2 hours, 28 minutes, we have 8 people finishing. So 8 people finishing is, and it looks like on the y-axis we're going by ones, 8 people finishing is right there. I'm sorry, I put it on the wrong, maybe. I meant to put it right here. Thanks. Wrong spot. What? So, well, this 8 is the 2 hours, 28 minute mark. Yes, we're using the right endpoint, basically. Next one goes to 11. So 11 is going to be right here. And then after 11, we climb to 20. And then 31, way up here. 43, way up there. I have to start scrolling up here in a moment. 50. 55, can I get it on there? 55, corresponding with the 2 hours 38 on there, correct? Or no? Did I miss one somewhere? Did I skip one? I'm sorry? Did I skip something? So this is a 32, right? So 32 should have been at 20. It is. Then 34 should have been at 31. It is. 36. Oh, I know. I made the fatal flaw of assuming that we went up by 2 each time. That's why. Yeah, that happens. I'm sorry. I was trying to do it without looking down at my paper to see that the times changed. So 36, and we should have had one at 38. 38 should have corresponded to 50. Did it? 38 corresponded to 50. And then 40 should have corresponded to 55, which it did. Okay, I haven't made a mistake yet. There it is. But now it jumps up from 40 to 48. And that happens. You just have to watch it. And I've seen that happen on IB questions. I should have known, because I've seen that happen. So we have to go all the way to 248, which is way out here, to get the next number, which is going to be 63. Well, I want this scroll. Oh, I'm going the wrong way, that's why. 63 should be right there. And then the last one is 69 at the 56 mark, which is right here. Where am I? This one right here. Now, this 100% line is representing 100% of the data. So that's what you're seeing on the right side. So on the left side is the actual times. Excuse me, the number of people. The bottom are the times. And the right axis is showing you the percentages of the data. If we connect the dots, and I had to do it like that to connect the dots, it looks like that. And cumulative frequency graphs will often look like S's. It's just what they do. Whoops. They look like weird S's. It is what it is. And I completely missed my lines, limit dots, which is causing me a problem here. So I have to redo it. I'm going to have to just do my best. S-ish kind of thing. They typically have this kind of look to them. They look S-y to me. Good news is, I've never seen an IB question ask you to construct one of these. They always ask you to analyze it. So they're not going to be judging you on your drawing skills. So now we can actually do question C. It says, use your graph to estimate the median finishing time. Well, the median would be what percent of the data? The 50% of the data, right? So the 50 tracks over to, I wonder how I did. Let's see. I'm going to use different colors for this. It's looking like this is the 25 and this is the 50, I believe. Something like that. For some reason, my stuff didn't line up perfectly. So if we wanted to sketch, if we wanted to estimate, we just track that 50 all the way over to, it's right around there. And then you would bring it down. Whoa, 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 whoa. I'm going to go home, dotted line, you're drunk. Let's try again. There we go. So there's your median. This is your Q2. And we're trying to estimate the time. Every little baby tick mark was 30 seconds, right? So it looks like 2 hours, 34 minutes, and 30 seconds to me. For the 50%, yeah. So we have 2 hours, 34.5 minutes. That's our Q2. We are trying to estimate, and does that make sense? Because I'm not going to, these things are kind of hard for a lot of people to read. Like I said, you're not going to have to draw your own. You're just going to have to be able to read it and use it. Estimate the number of competitors who finished under 2 hours, 35 minutes. So we need to go to 2 hours, 35 minutes. That's right here. And we're trying to figure out the number of competitors, not the percent, the number. The actual numbers are to the left. Things on the right are percentages. The actual numbers are on the left. That looks like that green one hit at 37 to me. So the number of people who finished in under that would be, you could say, right around 37 because it is an estimate. So the part 2 here would be about 37 competitors, about 37, finished under 35 minutes. Percentage, that means looking to the right, percentage of competitors who took more than 2 hours, 39 minutes. Let's see, switch colors. How about orange? 2 hours, 39 minutes is here. And of course, I'm not going to be able to see it, so I have to scroll. Good Lord. How did that happen? Magic. Okay. crud. Now, it didn't hit a perfect line, but so it says the percentage of competitors who took more than 2 hours, 39 minutes. Is it 75%? No, it's 25%. But the reason why it's 25% is because 75% of the competitors finished at this time or under. Remember, it's a race. So the more than is looking at that way. So 25% took more than 2 hours, 39 minutes. It's the remaining 25%. That's what it looks like using the graph, right? But that's because where did 75% land perfectly? We didn't know, right? I couldn't get a good line for it on there. So we can do what we did yesterday. Instead of just using the graph, we could use the actual numbers that we had in our cumulative frequency table. Remember yesterday when I was like, how many scores were less than 10, and the answer was like 8 out of 20 or something like that? We know there were 69 competitors. So we have the table of data. So using the graph, we could estimate 25%, but since we have the data, we could also do it that way, and we can get a more precise number. So we know that, was it 2 hours, 39 minutes? We know that we don't have a hard data point for 2 hours, 39 minutes, but we do know that 2 hours, 39 minutes is landing here-ish, right? So we could track that over, and it's about 52, about 52. This is just another way to do part 3. It's about 52. So we could also do, so this is C3. You could take the total number of people, you could subtract the 52, and then you could divide by the total number of people. And then, of course, you multiply by 100 to get a percent, right? And this is going to be about 26.4%. So I would say that this one's more accurate, but you can only do that because we had hard data and a picture. See, it was close to 25%, wasn't it? It's pretty darn close. And again, I'll tell you, the ones in the IB exam questions are exact. They're obvious. They're not like, well, it looks like it's about 52. No, there's always land right on things that they're asking you for. And part 4, time taken by a competitor who finished in the top 20%. So the top 20%, huh? Well, we would need to know what is 20% of the total number of people. I don't really have space to write anywhere. So this is for part 4. We're going to figure out what 20% of our population of our sample of 69 runners is. And we get 13.8. Okay, well, we're not going to, if we're talking about 13.8 people, we're talking about horror film land. So why don't we just call it 14 people? That way we don't have partial people. 14 people. So you're looking for the top 14 people. Which side of the graph is top 14 people on? Remember, it's a race. So the people on the left are your top people, not your right. Because as you go right, the time is getting longer. These are the race losers. Race winners are on the left side. So 14 people is right here. And it drops down to right around the 2 hours, 30 minutes, and 30 seconds range. Or depending on how your curve looked, you could say 2 hours, 31 minutes. It really is just how your curve ended up on your paper. It's not an exact science because we drew these by hand. Do you have a question? Oh, you sure? Okay. So there it is. That is, you could say, about 2 hours, 30.5 minutes, or 31 minutes, just depending on your hand drawing. And that's how cumulative frequency graphs work.